Okay, so we're going to go through this energy lesson 2 types of energy together. We're differentiating mostly kinetic and potential energy today. You should have already done your attendance. Hopefully you watched this video on your own, but we're going to get right into the simulation. There's this link is causing everyone headaches today, so I don't know what is up with it. When you click on the link, it opens to this weird format. It doesn't take you directly to the Google Doc. I will figure it out. But for right now, if you go to open with, right here in the middle, open with, you can select Google Doc and then you can just type it in there. So hopefully that works for everybody. You will still want to make a copy of it. Okay, so that we're not all on the same document. I'll close some of these tabs while the copy is opening. Okay. And so you should have your copy. You don't necessarily have to type your name. You're going to submit it to me under your name. But it says to start the FET, click on the first link, click on the play button, select intro. Well, those steps are already done for you because we have the simulation embedded into our Canvas lesson. So right under where you got the file from is the simulation. So we're going to just click on intro. And we've already got this running. So we'll stop our skater for a second. You will start out with this screen when you get started with the simulation. So you will want to click pie chart and bar graph. And let's kind of take a second to digest those things. The kinetic energy is green. So green for go. Kinetic is movement. Potential energy is blue. It's waiting. Thermal energy is heat, and it's orange. We're going to look at that as we go along in a little while, but we'll just kind of keep that in mind for right now. All right, so let's look at our instructions. It says, time to explore potential energy, kinetic energy. Okay, make your screen look like the picture by clicking the bar graph on the pie chart, dragging the skater to the top of the ramp, and releasing the skater. Okay, so we want to see both of these charts. We're going to take our skater to the top of the ramp. Now, notice, before you go any further, that pie chart above the skater's head is all what color? It's 100% blue. And blue stands for potential energy. So before I let go, he's got 100% potential energy. Okay, so let's just watch what happens for a second. Making what kind of observations can you guys make as we're watching this? Okay, so the higher he is or she is, the higher the potential energy is. Okay. What else? What happens at the low point? It's all kinetic. Okay. Notice over here at the pie chart, at the bar graph, what is going on with this gold bar? It's labeled total. So this is the total energy. Do you see any change in the total energy? No change in the total energy. These are changing, but if we add them together, we're going to get that same amount of total energy all the time. So let's see what questions we're supposed to answer. We kind of discussed that already. Use the symbols. I know it says symbols, but you are not writing, so symbols are difficult. You can just type in the boxes. So we're going to watch the skater goes down the hill. What happens to potential energy? What happens to kinetic energy? And then total energy. So, let's see. There he's going up, down, down. The kinetic grows and the potential decreases. So as the skater goes down the hill, our potential energy decreases. Okay. And I can't spell. That's okay. And the kinetic energy increases. What did you notice happen to the total energy? So we'll keep looking at them. stayed the same. And that's really an important observation to make as we the hell. I'll try to get in that box. We could just type down here. Notable technical difficulties today with this link. Total energy stays the same. Oh. I couldn't get to type in that box, but that's okay. We'll move on. As the skater's going up the hill, so up the hill, notice the potential energy increases. Potential increases, kinetic decreases. So we kind of have an opposite effect. So as the skater goes up the hill, the potential energy increases, and the kinetic energy is going to decrease. Okay. So let's look at total energy again. The skater goes up the hill. That total energy doesn't change at any point. So that's really important. Okay, that's really important that we make that note, that total energy always stays the same. All right. What happens if you drop the skater onto the track from above the track? Why? Well, I'm glad this isn't a real person, but let's grab our skater. Notice as I'm holding him way above, her way above the track, what kind of energy does this person have? Has all potential energy. Look at the bar graph over here. Down here next to the ground, we have a low total energy. What happens as I raise the skater above the ground? My total energy increases. It's all potential because I'm holding the skater still. But as I drop the skater, which don't ever do this to a person, do not try this at home. If I drop the skater, wait, I have to push play. What do we notice? That orange piece of the pie now. Now we've introduced this idea of thermal energy. Okay. So thermal energy is taking a piece of that total energy. Now think about real life. Okay. If you got dropped, what might be true? Friction from the air, right? That friction. He fell out of the ramp, didn't he? Because if he gets dropped from here, notice it's all thermal energy that's left there because it's all been transferred from that potential through kinetic to thermal energy. So that's a really important observation to make, that the higher I put the skater, the more total energy that I have. Notice the size of my pie chart too. It does change for visual purposes. All right. So you should have something right there on that line to type in there. Okay. And then as an object moves down the track, the kinetic energy, we can look at our data table for this. As the object moves down the track, the kinetic energy increases and the potential decreases. So let's get that in there. The kinetic energy increases. And the potential energy decreases. And the object moves up the track. So go back to our data table. And the object moves up the track, the kinetic energy decreases and the potential energy increases. Increases, that's not a word. Okay. Okay. Look at your data table and focus on the total energy column. Write a complete sentence about the total energy of the object moving up and down the track. So let's look back at our skater. I'm going to pull our skater up here and release them at the top of the track. And let's take a look at that total energy column. We've already kind of talked about it a little bit, but just notice it never changes. The top of the hill, the potential energy is almost exactly the same. At the bottom of the hill, the kinetic energy is almost exactly the same. But the total energy never changes because the total energy of the system is conserved. It stays the same. So it's an important observation to make from this simulation. So you should write that right here. The total energy never changes. All right. Let's look at our next question. Time to explore friction. What is friction? Before we go any further, you said something about friction earlier. Go ahead. Okay. It does take some of that energy up. Friction is that kind of roughness that slows the energy down. It's a force, right? So like think about when you're on ice. Is it hard to walk on ice? Yeah, because there's no friction. Whereas when you're on like the concrete outside and you have tennis shoes on, it's really easy to walk because there's a lot of friction between the soles of your shoes and that rough surface. So that's what we know about friction right now. Let's look at friction in the simulation. So it says at the bottom, click friction, click the box next to bar graph. Okay, wait, let's reset this. Okay, we're going to go to the bottom where it says friction. Okay, we already wanted pie chart and bar graph clicked. Let's take our skater off here for a second. Notice you can change mass, you can change friction. So we can make our skater bigger, we can make our skater smaller. We'll leave them about in the middle. And right now, let's just kind of make some observation. We have a little bit of friction. What is different with friction than it was in the first part of the simulation? He kind of slows down, right? Somebody said he slows down. Absolutely. So what if we have no friction? What do you think? Is he going to slow down or not? No. So our skater, she just keeps going. Just keeps going. Okay, so let's take the skater off there. Let's give lots of friction. What's your prediction? Okay. So notice almost immediately they start to slow down. And then we have this other thing creeping up. Thermal energy almost steals away that energy from the kinetic and potential because of friction. So let's try our skater again. Notice at the top, we have all potential energy, just like in the first part. We start to go the same things. Potential energy decreases as we go down and increases as we go up. But that thermal energy is beginning to take away from kinetic and potential until we come to a stop. Okay. Have you ever been skating or been on a skateboard and when you were done, the wheels felt hot? Ever? Okay. Or like how many of you have maybe worked on a car and the brakes got hot? Why do brakes get hot? Essentially, because of friction. This thermal energy builds up inside where those pieces are, like in brakes, they're rubbing together to cause the vehicle to stop. Same concept. It's exactly the same thing that we're looking at. All right, so what are we supposed to be answering? So same concept. Downhill, the potential energy does what? Well, potential energy goes down, kinetic goes up. So we're going to see that same pattern as we did up here. So down the hill, potentially decreases, kinetic increases. Let's go ahead and put that in our data table here. Down the hill, the potential energy decreases, and the kinetic energy increases. Up the hill, we have the same idea. The potential energy increases, the kinetic energy decreases. If I could spell, that'd be great. Let's look at total energy one more time. So I'm going to make the skater go down the ramp. Does total energy change? Total energy is conserved. That is a law of physics. Energy is conserved. So the total energy of the system stays the same. But I said it was just like the table from before. If we go up and look, it only had 3 energy columns. But this one has a 4th. That's for thermal, right? Good observation. And I might have to delete that line to make it fit. Okay, so I put thermal in there. Okay. And so let's look. Thermal energy. As we go down the track, it goes up. As we go up the track, it goes up. So thermal energy is increasing the whole time until it finally takes over and matches the total energy. So all of the energy has been converted into thermal energy. So this idea that friction takes away our movement, takes away our saved energy, turns it into heat is a concept that really affects our lives. Like we talked about brakes a little bit ago. And thermal energy increases in both of them. Okay. We kind of discussed the patterns that we saw in the data table, how they were the same. So as the object moves down the track, the kinetic energy increases, so down. The potential energy decreases. So you're going to kind of keep this one in mind as we continue to talk about energy. What does total energy always do? Stays the same. Total energy is always the same. Okay. All right. So after watching the bar graph, while the object is moving, especially with lots of friction, write a title for the last column. We already did that. We added thermal to that. So the title that we put was thermal. Okay. As the skater moves with friction, the kinetic energy and potential energy both do what? So let's watch the skater again with lots of friction. Notice the kinetic energy and the potential energy are both going smaller. They don't rise as high, so they both decrease, whereas the thermal energy is increasing. So kinetic energy and potential energy both decrease, and thermal energy increases. What does total energy always do? Stays the same. Okay. So then write a possible explanation for this. So think about like real life. Write what you see, and then I'll give you a minute to get that explanation finished. So let's look at, we kind of already discussed that, but which situation with friction or without friction is more similar to your everyday experience on a skateboard or bicycle? What do you think? When you are on a skateboard and you get going really good, are you just going to keep going as fast as you're going? No. What's going to happen? You're going to slow down. Why is that? Friction. Because of friction. Okay, so write something about that. I'll give you a couple minutes, then we'll talk about the playground, and you're going to be expected to answer the rest of the questions. So write something here. Okay. All right, so it says finally click playground at the bottom and create a track with at least one loop. Drag the segments to make loops. I'll show you how to do that in a second. It says here draw a diagram of your track. You could just take a screenshot and put it in there, or you could even just describe it in words, and I'm kind of okay with that. But then you are supposed to answer these questions on your own. Okay, so let's talk about how do you make your own track. If you come down here to the bottom, it says intro, fiction, playground. Playground's what you want to click on, and that's what I was playing with earlier. So if you reset it, this is what you come to. You want to have all those same things, okay? But then you drag these out, and you can pull them, you can change all of these things. You can also pull out more, and you can attach them. So you might have a bunch of them. I don't know. Okay, so I don't know. And then you're going to take your skater and you're going to put them on the track. I didn't make it around the loop. So you want to try to make it around the loop. Maybe I need to go a little bit. I don't know. Oop. Didn't make it. So play with that and try to get them to go around the loop. And then you're going to answer these questions on your own. So you are responsible for those questions. When you're finished, you're going to go up to the top. You're going to say file, download as a PDF document. And then you are going to submit that PDF document. Okay? All right.